you want me to give you any signal? Or?
Yeah, how long do I have?
You should probably shoot for finishing around 12:30 or so there's time for questions.
Okay.
Is that going to work okay? Do you think?
I don't know.
Okay.
Yeah, it'll work. I'll make it work. I put 2 presentations together and I haven't run through it, and
Okay.
I'm actually
Well,
not
we'll
sure.
see.
So it'll be fine though.
That's fine. If you're like going way over, I'll making faces or something.
I'll see. The clock is by the second.
Yeah, and apparently it is accurate. I'm
Okay.
waiting for this to show up. We're ready. Are you ready now?
Yes, we're ready.
Okay, it's not up here yet. That's why I wasn't clear.
Yes, we'll bring it up as soon as I get it.
Oh.
Okay.
We're waiting for the webcast to start. Sorry. It's so quiet in here. Well, while you're here, actually, I don't need to webcast this. I have organized for the 4th time a Urban Studies and Planning night at the Beavers game, which happens to be tonight. I have 3 tickets left if anyone's interested in joining us. We have at least 50 people going tonight, so it should be fun. And it will stop raining before the game. Why aren't you up yet? You're on? It's
They
not.
didn't want the monitor on, is why it was.
Oh, I'm sorry.
It made them nervous, but you're on, so just.
Okay.
I was sorry.
Sorry about that. I was waiting for the monitor. That's never going to come on, apparently. So anyway, my name is Jennifer Dill. I'm a professor in the School of Urban Studies and Planning, and along with Chris Monsieur and Rob Bertini, who unfortunately can't make it today, we organized this weekly seminar. And this week and next week, we're pleased to have some of our own students presenting, which we try to do every year, usually about this time when they're finishing up and about to graduate. And I mentioned a couple minutes ago before we were on camera the reason I'm dressed in the Beaver sweatshirt is because we're all going to the Beavers game tonight. So that explains my less than business attire for today. So anyway, without further ado, I am going to introduce, I'll say both of our speakers and I'll reintroduce our second speaker. We have 2 topics today. The first is Steve Hansen, who is a Master's in Urban and Regional Planning student here at PSU who will be graduating in a couple of weeks. And he's going to be speaking about a project he's been working on with Rob Bertini and Chris Monsieur called Portal. And then secondly, we have Tom Moes, who's also a second-year MURP student who is also graduating, talking about school siting issues. And I'll reintroduce him when we make the switch about halfway through. So without further ado, Steve.
Thanks, Jennifer. As Jennifer said, I'm a graduate student in the School of Urban Studies and Planning, set to graduate in less than a month. And first off, I would like to thank Dr. Robert Bertini for giving me the opportunity to do this research with him. It's been a great opportunity, and also thank him for working hard to get the funding for this project, which is National Science Foundation Career Grant. So I'm here to talk about Portal, which is the online regional transportation data archive for the Portland region. It stands for Portland Transportation Archive Listing. So I'm going to talk about, first I'm going to talk about the National ITS architecture and the Archive Data User Service. I'm going to describe the architecture of our database and describe the database processing and storage that we do. And then I'm going to talk about some performance measurements that we've created, and also talk about a travel demand forecasting improvement project that's currently in progress, and also some next steps for after I graduate. So some of the guiding principles behind Portal, data are too valuable to use only once. So these transportation agencies are collecting data, maybe using it for a specific purpose, but not archiving the data at the highest resolution. And we feel that if that data is being collected, then it's valuable to archive it and store it permanently. And also, management of the transportation system cannot be done without knowledge of its performance. And if you have all that archived data, you can make better decisions about your transportation system. The U.S. Department of Transportation realized this a while back, and that's why they created the Archive Data User Service in 1999. And their vision was to improve transportation decisions through the archiving and sharing of ITS-generated data. And some of the principles behind ADIS are that all ITS deployment should consider data archiving. We should archive data to maximize integration with other data sources, archive in a way that eases retrieval for those with access, and provide useful information. So we've kept these principles in mind as we've developed Portal. And Portland State University is the regional center for collecting, coordinating, and disseminating variable sources of transportation data for the Portland region. And here's a picture of the new engineering building, which is currently under construction, and also a prototype of the new ITS lab, which I, unfortunately, or fortunately, depending on how you look at it, it's going to be a nice lab. So I think future students are really going to benefit from that. So a little bit about the regional data sources. There are 98 closed-circuit TV cameras throughout the region, 19 variable message signs, 485 inductive loop detectors, 135 ramp meters, and there's also several weather stations around the region, and TriMet is also collecting information about their buses, and this is all connected via a fiber optics network. So what I'm essentially going to talk primarily about is the inductive loop detector data. And for those of you who are not familiar with what an inductive loop detector is, it's basically an inductive wire embedded in the freeway. And this picture, you can kind of see them. If you haven't seen them on the highway before, I guarantee the next time you're driving on the freeways that you will see them. They're either shaped in a circle or a diamond. And when a car passes over that inductive loop, it knows that something metal is on top of it, and it registers. So there are 485 of these detectors throughout the freeway system in the Portland region, and every 20 seconds it sends information about how many cars have passed that detector over that 20-second period, the average speed of all those vehicles over that 20-second period, and also occupancy. Occupancy not being the number of people in the vehicle, rather it's the percentage of time that a vehicle is occupying that detector space. So those are the three main pieces of information that we're receiving from every detector in the freeway region every 20 seconds. And previously, before Portal went live last July, so it's going on a year now that we've been archiving this data. Prior to that, ODOT was aggregating it to 15 minutes and storing that data, but when Portal went live in July, it was the first time that the data at the 20-second resolution was being archived. So this is a little bit about the flow of the data. We have the loop controllers, and via fiber optics network, it goes to the ODOT Traffic Management Operations Center, and from ODOT, it goes to PSU, and I'm going to talk a little bit more about our servers. So we received a grant from ODOT to purchase new equipment, which we just started using recently, a few months ago. We now have over 1 terabyte of storage space, so we were able to purchase that storage, so we can archive all of this data permanently. And we also purchased a new database server, which has a dual Spark processor, and it's running a Sun operating system. So we have the best technology. So this allows us to store the data indefinitely, and also processing speed is very efficient. Let's see. So basically, we created a web interface to make it easily accessible to people who don't know even anything about databases. And this was all done in PHP, and the relational database is PostgreSQL, for those who are interested in that. This is actually, I don't have a picture of our new server, but this is a picture of our old server, which is basically just a PC. So it was a very significant upgrade. So we're pretty excited about that. Next I'm going to talk about the user interface. So this is all accessible for users via the web, and I'll give you the address at the end. And I encourage all of you to, if you're interested in taking a look at the data, sign up to be a user. So this is the portal homepage, and this map is actually from the ODOT trip check website. So one of the things that they were using the 20-second data for was to update this map. And every 20 seconds, this map is showing the current speeds on the freeway system. And I'll talk more about that later. But I'm going to talk about a few of the different screens that we have that allow users to extract information from the database. First, I'm going to talk about the time series page. And this plot is showing for January 6th of 2005 speed on I-5 North. And on the x-axis is time, so I'm showing the entire day. And here's the milepost for I-5. And then the different colors represent the speed for that point on I-5 for that time of day. So you can see pretty clearly that in both the AM peak, there's some congestion that begins around milepost 300. And here's the I-5 bridge. And if anybody's ever driven I-5 around that time, they know that some congestion starts here, and you can see it propagating back. So this just gives a little snapshot of what happened on the system for that day. So we can also, that was for all of I-5. We can also look at a particular individual station for that day. And this is just a two-dimensional plot showing volume of vehicles for the loop detector station at Going Street on I-5 North. So in addition to the loop detector data, we're also collecting weather. There are several stations throughout the region that are collecting information on the current weather. So we're collecting that data. So when you run a query, you can see what the weather was like for that day. So you can see maybe it rained a lot for a day and speeds are lower than normal. Or if you, so we have that option, and it's a little weather pop-up button, so you can get the weather for that day. We also have a group data page. So the previous queries that I showed you were just for one particular day. The group data page allows you to see what was going on for, say, in this particular query, it's from September 1st until October 31st. So for all of September and October, we can see this graph is showing for Portland Boulevard on I-5, it's showing the average speed by hour of day, and then it's also showing the standard deviation of speed. The error bars represent the standard deviation of speed. So you can see how the average speed drops at the PM peak, but also the standard deviation increases. So there's more variability during those times. We also have some monthly reports. It's on the performance tab, and it's a little hard to squeeze this into a presentation. But so basically, this is a monthly report for the month of April of 2005, and this first graph is showing the blue bars are showing the congestion frequency. So that's the percentage of time that there was congestion for that time of day on, let's see, we are doing I-5 North. And the green is the vehicles per hour, so essentially volume. When you scroll down, you can get the estimated travel time. So the green line is the average travel time for the month, and the red is the 95th percentile travel time. So essentially, 5% of the time travel time was greater than that. 95% of the time, it's going to take this amount of time or less for that time of day. And then we also are showing vehicle miles traveled and vehicle hours traveled for the month. And we can also show, one thing I wanted to mention when we're talking about travel time, I just wanted to quickly go over how we calculate that. Basically, we have, for each detector, we have an influence area, and we're assuming that vehicles are traveling the same speed through that entire influence area. And the way we define the influence area is from the midpoint between detector A and detector B is right here, and between B and C is here. And the influence area of detector B will be from that midpoint to this midpoint. And in the case of the end of the beginning and end of the freeway, it will be the ends of the freeway. So we're assuming that the speed that the vehicles are traveling at detector B, that they're traveling the same speed over that entire period. And we do have another project, another student in the ITS lab is working right now on seeing how accurate this calculation is. So basically we're taking probe vehicles equipped with GPS, handheld GPS devices, so we know the actual travel time, and we're going to compare this to the calculated travel time from Portal. So that's another project that's going on. But I just wanted to mention how we're calculating travel time on these pages. So the monthly reports that I showed you are also available in tabular form, and here's the information. And one thing that's interesting about this is that the U.S. Department of Transportation it puts out an urban congestion report, and Portland is not. There are right now. It's kind of in the testing phase right now, and I think there's 10 cities that are in this study, and Portland isn't one of them. However, the information from this performance report that we can create, we have the same information that's going into these congestion reports for the Portland region, and we kind of added it into the report here. One of the other things that we're working on that's not live yet, but getting pretty close, is to be able to create some maps. So the maps, this is showing, this is similar to the ODOT trip check map that I showed you, which is, this is kind of showing speed at one point in time. But we can also show average speed for the month. In this case, this is November 2004. And we can also show travel time index. So in the monthly report that I showed you a few slides before, we can also show this on a map, and it's a lot clearer. It's a quick snapshot, so you can really, in one slide, really understand what's going on in the freeway system. So we're working on this right now, and eventually we're going to add this to Portal, so users can actually create their own maps for whatever data they want. So I want to talk a little bit about data quality. I mentioned the 3 pieces of information that we're getting, which is speed, volume, and occupancy. We're actually getting one more, which is, we call it a status. It's basically the status of that detector for that time. And that's what we're using for data fidelity. And it's ODOT has created an algorithm for their ramp metering system. Currently, the ramp metering system is static, meaning that the ramp meters are at the same time every day. The ramp meters let the same number of cars go by. They're working on eventually making that dynamic, so it'll be dependent on the what's actually happening on the freeway. So if there isn't any congestion, they can let more cars on, or if there's congestion, they'll slow down the ramp meters. And they're using this is the algorithm that they're using to determine what information they're going to take from the detectors that's going to go into determining the ramp meter timing. And essentially what it's doing is it's comparing upstream and downstream. It's looking at the upstream and downstream detectors, and it's looking at the number of cars that are passing those detectors. And then it's comparing them to the detector to see if the results are reasonable. So if the upstream and downstream detectors are all showing a volume of 10 or 15, and then the detector that we're interested in is showing, say, a volume of 2, the algorithm kind of flags that and says, that doesn't really look right. Or if, say, it also looks at the neighboring detectors. So if the speeds of the neighboring detectors are 60 miles an hour and the detector that we're looking at is 10 miles an hour or 90 miles an hour, it also flags that and says, maybe that's not a good record. So there are different status types. Disabled just means that there's maintenance going on with the detector, or it's not working for whatever reason, so it's essentially turned off. Communication error means that occasionally the fiber optic system gets overloaded and the data doesn't get sent properly from the detectors to the ODOT operations center. And when that happens, that's flagged as a communication error. There's also an error occasionally where from ODOT to PSU, we don't get that data stream, and it doesn't happen that often, but sometimes if things are getting updated or if the server gets overloaded, sometimes that data doesn't make it to PSU, so we also flag that. So as far as the good readings, we have sometimes if there's no activity, we consider that a good reading. If the algorithm, sometimes the algorithm will determine that a record is okay. If things look a little bit funny, it'll go to suspect. And if the records are either suspect for a while, or if they're if it's more out of line, it'll go to soft fail and then hard fail. And then so it'll go to hard fail until that detector starts reporting good data again for a certain period of time, and then it'll go back to okay. So we actually have a tab where you can look at whether the data was good. You can look at a particular detector and see whether the data was good for a certain day. So that's helpful if you're using Portal for some analysis. You want to first look to see what the data was like for the detectors that you're interested in, to see if they're giving good data. And you can use the Data Fidelity tab to do that. We also have a button if you create a plot in, say, the time series page. You can click the Fidelity pop-up button, and it will show you the percentage of good records. So in this example, blue means that most of the records were good for that particular detector. When you're getting down to green and red, those aren't quite as good. So this is a case where you might want to look at what was going on in these detectors, because it looks like only 60 or 70%, and there's some red, so it looks like there could be some bad data. So that might be something where you'd want to look a little closer at those particular detectors to see if you'd want to use the information from here in any sort of analysis. So let's see. I think I have about 5 minutes. So I'm just going to quickly talk about the Oregon Highway 217 study that we were doing with Metro to help them improve their travel demand forecasting model. So this project actually occurred prior to when Portal went live. So ODOT provided us with a week of data, April 14th to April 20th in 2002 for these detectors on 217. And what we're doing was trying to come up with a more accurate volume delay function, which is the relationship between the volume on the freeway and speed, or also delay, on that segment. And previously, Metro was just using standard functions from the Bureau of Public Roads, and this is kind of the standard function. And they wanted to see if using the loop detector data, if they can get a more accurate representation of that relationship between the volume on the freeway and delay. So this is the old VDF. I showed what I was showing you was this function, this BPR function. They actually modified a little bit to basically when the model runs, it converges faster if they use that function. I'll give you all a minute to write that down. But basically, the canonical function has the same properties as that other function I showed you up to up to the capacity of the roadway. So it basically helps in model convergence. It's not that important. So the first thing we needed to do was convert all the volumes to passenger car equivalents, because right now there's actually on the system right now we have dual loops, which means at each detector location there are 2 inductive loops, and it has the capability of actually collecting the vehicle length, and we can transfer that into so we'd have both cars and truck counts. And they're working on upgrading the detectors so that they will be able to count, distinguish between cars and trucks. Right now it can't. So we have to take the volume data and convert it to a passenger car equivalent. So we took information from December 31st, 2001, got the number of trucks that were passing on 217, and ended up with a passenger car equivalent of 1.016. So basically all our volume numbers were multiplied by this number due to the length of the trucks to get a equivalent of passenger cars. And that's what's used in the volume delay functions. So here's the volume capacity ratio versus the travel time for Hall Boulevard on 217. So you can see the total travel time increases as expected as the volumes increase. So this is the results. Again, I'll give you a minute to copy these down. After looking at all the data, Metro decided that they were going to create 2 volume delay functions, a high and a low, and they picked the high or the low based on which was the best fit for that particular station. So it's a little hard to read, but the triangle is the canonical function that I showed you at the beginning, and then this is the high volume delay function, and this is the low volume delay function. So they were pretty happy with the results. They thought it looked reasonable. And right now we're working on doing the same thing for several other detectors areas around, not just on 217, but all the freeways in the Portland region. So that's kind of the next steps. Some other next steps for Portal. So I just talked about loop detector data, but we're also We'd like to start getting data from TriMet. We actually, just a couple weeks ago, started getting data from Washington State. So that's actually happening now. There are also detectors on arterials throughout the city of Portland that we could potentially archive, as well as weigh in motion data from ODOT. So again, I'd like to thank the National Science Foundation for providing this grant to Dr. Bertini. And Dennis Mitchell and Jack Marchant at ODOT have been very helpful, as well as Bill Cluse at the City of Portland. And there are some other staff members that I'd like to acknowledge. Andy Delcom, Spicer Matthews, Andrew Bird, and Andy Rodriguez are all in the computer science department, and they've all been working on this project. Peter Bosa and Ahmed they're currently working on the mapping. And that's about it. So like I said, I encourage you to, the website for Portal is portal.its.pdx.edu. So I encourage you, if you're interested, to go to the website and sign up for an account and let us know what you think. So thanks a lot. I'll take questions
We'll
now.
open it for questions. And I forgot to remind people to use the microphone in front of you when you ask questions so that people on the web, and people are watching on the web, can hear your question.
Steve, you mentioned that sometimes there is data stream failure and you don't receive the data from ODOT. In that case, do you receive it later or?
No, because ODOT doesn't keep it. So if we don't get the stream, then we unfortunately miss that. And it doesn't happen. It actually happens probably less often than communication failures on the ODOT end. Most days it's well under 1% of the records. Sometimes what we're working on, sometimes if there's a really intensive CPU intensive query that's running, it overloads. So we're trying to work that out to make sure that doesn't happen. But it hasn't really been too big of a problem. Oh, go ahead.
In the current website, when you query, you can see those graphs all instantly? Where you see those speed plots and everything?
Well, define instantly. It takes a few seconds, but not quite
it
instantly.
works.
Yeah.
You said you're going to be aggregating more data from other states and possibly other collectors in the region. What's your server capacity for that? How much can you do you think? Can you add, I guess I should say?
Well, I don't know the exact. Well, we have over 1 terabyte of disk space right now, currently, and we can always expand that. So I think we're seeing it as fairly endless. And like we were talking about, for the most part, I don't think there's going to be a problem as far as streaming that data in. We're having, like I said, occasionally we have a small glitch, but we're working on that, and I don't think that'll be a problem because our processors are, I can't remember, they're probably one of the fastest that are out there. So I mean, we do have top-of-the-line equipment, and as far as other data sources, it's going to be Washington, state of Washington, and TriMet Data, and the City of Portland data, and that would be about it. That would be, as far as data, that would be constantly streaming in. So we think that we're set up to handle that.
Regarding some of that other data from the TriMet and City of Portland, is the data going to be sent in the same format, similar format, or is there going to be a lot of work that needs to be done to sort of get the data in a similar format to the ODOT data?
Well, the Washington State data is in the same format. As far as the other data, we haven't really gotten that far yet. As far as the best way to stream that in.
What causes some of the faulty data to be collected by these detectors? I mean, if they're working, but just...
Yeah, well, sometimes there in a lot of cases, it's construction. So either maybe the detector didn't get turned off during construction. You have a piece of machinery sitting on the detector all day. So that happens sometimes. Other times, it's just a calibration issue as far as how sensitive they are. And there's another. I talked about how we have the dual loop detectors, but we're not using. They're not set up to count trucks, and they're also not set up to. They're not measuring speed. The speed is actually calculated based on occupancy. So we're taking an average vehicle length and looking at the occupancy and calculating speed based on that information. So if you have a lot of times at night, a lot of trucks are passing, and the speeds will look really low, and it's because we're taking that occupancy from a long truck and using an average vehicle length, and it looks like there was a car passing really slowly when in fact it's a truck passing at normal speed. So another thing that we're working on is to impute the data to kind of fix those things, and we're looking at an algorithm that basically determines how many trucks passed over a certain period. So so kind of the next step is to work on improving the data so that we can kind of correct some of the errors that happen. Jennifer?
I have one question from me and one from the web. And the question from me, I think, is quick, and that's from Washington DOT data. Is it the whole state of Washington or just
No, it's just
Vancouver?
Vancouver,
Okay.
yeah.
And then the question from the web was about, you had a graph that showed the standard deviation at some of the peak times. The standard deviations were really quite huge. And the viewer was wondering if that might have anything to do with the HOV lanes that are in the peak hour only, or what do you think might be going on?
Let's see. Well, I don't know. Well, one of the things is that it looks like in the group data, you have the option of including all days, or you can just include weekdays, or you can just include midweek days. And it looks like this query was done using all days. So this is going to be both weekdays and weekends. So that would have a lot to do with it, I would say. But you are going to have more variability from day to day, even during the week. So I would expect, even if the query only included weekdays, it would be normal for the standard deviation to be higher during the peak period. So, Jerry?
Are all the lanes in the three-lane freeway covered with these loops, or just certain lanes?
At each detectors are always at an on-ramp, so we have information on all of the lanes at that on-ramp, as well as we have the count of cars entering the freeway from the ramp counts. So wherever there are detectors, they're always covering all lanes.
I have a flurry of email questions from the web. You mentioned the coding of how the quality of the data, and there was that suspect category.
Right.
And the question is, how do you, before it goes from suspect to soft bad or hard bad or whatever it was called, fail, if it's suspect, how do you determine whether or not you should use the suspect data?
Well, that's kind of an ongoing question that we have right now. Right now, we're using the suspect data basically because ODOT is going to be using it with their ramp metering system. So that was kind of the justification for including that as a good reading, because ODOT was considering it as a good reading in their algorithm. But I think that leads to a good point, is that this is kind of a work in progress, especially with the data fidelity, and so we definitely are we are in the process of looking closer at the data and really figuring out trying to improve this algorithm. So it is kind of a work in progress.
Additional questions? Well, we should thank and then Steve, and then I'll introduce our next speaker. Location. So we're going to make a little transition here to our next speaker. That was quick. Who is Tom Moes, also a second-year MURP student who, again, will be graduating within a few weeks from our program. And he's going to be speaking about some work that he's been doing on his field area paper, which is part of his degree here on school siting issues.
All right. Thanks a lot, Jennifer. And I just want to say again, my name is Tom Moes, and I've been going to the School of Urban Studies and Planning now for the past 2 years. I plan on graduating in June. And my areas of study are mostly in transportation and land use. So I just want to say thanks and appreciate that I get the opportunity to present today and talk to you a little bit about my initial findings, actually, of my comparison of school facility plans in the Portland metro area. And I just wanted to start by saying the reason why I chose this topic is because I always grew up biking and walking to school. If I ever woke up late, I never had a choice but to bike or walk to school. I was never driven. And so after college, I moved out to Portland and I started working with the Bicycle Transportation Alliance, teaching bicycle safety education, trying to encourage kids in elementary, middle schools in Portland to bike and walk more to school. So when I got to college, it just got real important to me to maybe look beyond the educational aspect and see what are some of the barriers that for kids not walking and biking to school. And so that's how I got to where I am today. And so I just want to cover a few topics. I can't go in depth in everything that I've been researching today, but I'm going to try to make a few connections, and feel free to ask me questions at the end to help clarify where I made maybe a connection from some of the research, but I can't present all of my background research necessarily today. So I'll talk a little bit about the school facility planning, why it's important, my field area paper, the questions that I ask, the methods I approach to answer some of those questions, a statute that mandates why these schools have to do school facility planning. There's a superintendent survey done, kind of give you a little bit understanding of some of the issues with school siting, trying to bring in some of the transportation aspects of it because my paper mainly focuses on the land use. I also want to talk about just some of those initial findings from those plans. In many cases, I'll bring up examples from the Beaverton School District, and then just some general conclusions that I've made from what I've done in my research. And I just wanted to show you real quick, these are some of the thick plans that these schools write when they write these comprehensive school facilities plans. And so I'm almost done reading them. But I still have a little bit ways to go because they're thicker than a lot of planning documents I've actually looked at. And so school facility planning is mainly used for capital construction improvement plans. I'm not going to be necessarily focusing in on the educational aspect of it today. And that's for improving existing school facilities. There's many different issues in terms of rehabilitating schools, renovating schools in urban areas as opposed to building new schools with more enrollment, with people moving out to suburbs, and then just projecting those needs. And then I'm not going to go into great depth today at all about the voter-approved bonds issue, but it's a pretty major issue when it comes up to school siting challenges and how they're going to pay for these capital costs. It's the only way to actually pay for these capital costs in building these new schools. And so what's interesting is that the state of Oregon says that it's paramount that all school-age children be provided with an education. And so schools have, as I've learned in some of my interviews, are taking on this greater responsibility for more land use planning. and anticipate the enrollment growth based on the demographic projections. And I've had really lively discussions with some of the people in the school field about the lack of connection sometimes between them and planners. And so I just have a couple basic research questions about how these school facility plans address and actually overcome school siting challenges is when I start looking into this project and this research. And then there's definitely transportation, land availability, costs. All that comes up in all these challenges, and I'll present some of them to you today. But again, I won't be able to present everything that I wish I could in the time we have. And then some of my other research questions, these are kind of some of my earlier questions that I asked when I started doing this research about the current challenges in selecting to build new school sites. And I'm mainly focusing in on elementary, middle school in the Portland metro area. And then when I started doing my research background, this is one of the first questions I asked about self-contained neighborhood schools, fostering stronger relationships with the surrounding communities. So in other words, if I was doing a full-blown transportation paper, I'd look at the benefits, perhaps of biking, walking to school. I could use GIS, Geographic Information System type techniques to measure street network and how streets are designed and how kids travel, and that safety environment to school, proximity to major activity generators or arterial streets as well with that question. But I'm mainly using that as a backdrop. And so I just wanted to, I'm going to switch a couple times throughout my presentation to show you some maps so you guys understand where these schools are. And the first one I have is right here in our backyard. This is Portland Public Schools. This is a map I've just downloaded off of the internet to show a little context of where many of these schools are located. I know it's hard to read, but these are just all the different types of locations for the Portland Public School District. And then what's interesting, though, in this case, is the Beaverton School District, and here's a vicinity map of that. There's Portland in the green. And then this is this is Beaverton School District. And feel free to ask any questions at the end to clarify anything with this. But I have this other map that's a pretty useful map for Beaverton, which shows in terms of urban growth boundary expansion and why some of these facilities are needed. This shows what's projected in terms of new urban growth boundary expansion areas and how many dwelling units they plan to build on these outer edges of the school district. And so obviously it's a pretty important need to build these schools and for planning for these school sites. And this is, as you know, Beaverton's in more of the western suburb. And then this is Tualatin. It literally is just below Beaverton right here. Just wanted to kind of just show you this map to provide some context. It's two cities there. And then this is Wilsonville, West Lynn. And what was interesting about this interview, just to state up front, is that one of the persons who I interviewed said it was a tale of two cities. One city was really good to work with one of them, and the other city was kind of some friction at times of how they would build school sites. So that kind of made it into my report, and I'll explain that a little bit more in depth. But this is kind of an urban growth boundary area expansion. And I'll discuss what some of the issues come up when they look at expanding some of these areas within Wilsonville, West Lynn. And so some of my research methods, what I did was I kind of started out with kind of looking at theoretical background, the neighborhood unit concept. I've talked about this quite a bit in my planning program, and that's just more of building schools as neighborhood centers. And as you can see in this diagram, this was by Clarence Perry back in the 1920s, and it was a closed system that had some basic elements in it, with the school in the center, surrounded by small buildings, human scale configurations, with as well as streets that were easily accessible. This other map shows a little bit clear understanding of how some of that street network was and how kids travel to environment, how they plan for that, how a lot of neighborhood schools are important. In Portland, that is, are planned with this similar type of theory and this idea of having schools as neighborhood centers and kind of in the center with adjacent land uses with parks next to it. And so some of my other research methods, just real quick, where I've just started looking at, when I started finding out what was in these plans, it was important to look at school enrollment trends, the reasons why people move to suburbs, kind of the history of all that and the effects of sprawl. Some of the challenges I talk about with the superintendent survey that came up. I have other information that I looked at as well. Is there kind of a connection, and this is kind of could be one of my research questions as well, between the suburban residential zoning regulations and transportation policies, and that comes up in some of my research when I looked at, and I'll talk to you about that with Beaverton. And then who's responsible for building these schools and financing them, planning them, doing all the construction. I'm not going to necessarily talk about all the construction or architecture. I'll do a little background with that, that revised statute, 195.110, and then if you have any questions about the last point, I can certainly try to answer some of them, but I'm just doing some background research on that as well. And so what I basically did was I conducted interviews with all the school districts now to find out about how these plans were written and what the process was, and they range from, no one has a real clear title of a facility planner. I did deputy superintendent, real estate manager, capital improvements manager, and a facilities planning, I guess, director, but he deals mostly with maintenance. And so they're real big advocates for building new schools, but the first thing they'll tell you is where are you going to get $130 million to help plan for building those schools, and where is all this land available? So it was really interesting discussions. I have quite a few notes on all these that I've conducted over the last 2 months. And so from there, this is kind of some of the criteria that I used is with some of those questions that I asked them about what's the purpose of these plans, the planning process, the involvement, how long some of that involvement was, some of the guidelines I used for selecting new schools and building them, and then some of those challenges, the conflicts, if any, arose during the plan preparation, other planning policy documents. I was always suspect about this one if they've ever consulted them, but it turns out that they do a really great job of, they have to actually, of consulting different types of metro regional 2040 planning documents and other city county comprehensive plans as well. And then I threw in the question about physical activity and active living ideas, which actually I think I should have clarified more up front when I presented that question to them, because no one thought about it in the sense of kids walking or biking more to school. They thought about it more in the joint uses of how those schools could be used to increase Little League soccer, and it was quite interesting to hear some of those, but it was good responses too, and that will make it in my report. And so if you ask who these plans were prepared by, basically not schools. They don't have much funding to do any of these in-house. They have told me there's no real state planner, facility planner that comes and helps them write these plans, so they hired private consultants. And it turns out that Angela Eaton Associates did 2 of the 4 plans, so they already got 50% of the market already, and there's more plans that are being written, and also Parsons Brinkerhoff Innovation Partnership. And so this revised statute, why these plans are written, is because that it states, this was back in the early 90s when this was passed, that high-growth school districts with over 5,000 students, they have to have an enrollment of 6% or more during the 3 most recent years. And that basically, this basically makes schools a priority, or makes the planning for school districts, makes planning a priority of why they do that. And so this is a little graph that I put together. It was done in one of the appendices of my school facility plan. I'm basically trying to show what student enrollment was, and you can download this off the Department of Education website from the state of Oregon. And actually, Beaverton at the bottom, if you note, they actually slowed off in growth for the past 3 years. Between 2000 and 2002, they had over 2,000 students enter into their schools. Interestingly enough, as you see that the Portland Public Schools, had approximately 4,000 students leave, and almost 45, and then I just put the approximate number of 89 because I'm not too sure after all the closings that are going to happen what the actual number is. And West Lynn only was a high-growth school district back in the early 90s. As I know today, Oregon City hasn't been doing any type of writing any type of plan, though it doesn't mean they're not planning for future sites and schools and looking at what types of areas they want to plan and build schools on. And David Douglas, Gresham Barlow right here, and Forest Grove were actually high-growth school districts back in the early 2002. So even though the growth has slowed a bit, it's still growing each year. And so basically, this problem that they need to address with school facility planning are these major points up here. And this is the real technical aspect that I'm not doing a lot of analysis on, except trying to explain the comparisons and differences between population projections. But the desirable school sites, some of the physical improvements, the financial plans to meet these construction needs, the analysis of alternative sites is a real interesting part of the studies. 5-year capital improvement programs, which you might ask, why only 5 years? Since bonds are mostly try to acquire every 5 years and to pay for schools, and they're supposed to set up for those bonds to have money set aside for future school sites 5 years from now. And then just the plans and schedules of how they go about that. And so this survey was done in a community or University of Oregon workshop where they asked out of 197 superintendents, they sent out 156 surveys and got a 52 response rate with 81%, 52 with 81 surveys sent back to them. And so this just kind of looks at the school siting practices, future school siting needs on a statewide level. So they asked the factors, as you can see, affecting school siting decisions. And as you can see, the ones that are highlighted, the respondents identified land availability, long-range planning, and financial factors as the most important factors. And then what's notable, though, after talking with the person that helped set up and design this survey, is that the 29% of people that indicated school design, as you can kind of see over here, said that it's not necessarily a consideration. Also, 37%. They rated the same factor as a 4 or 5, which you can see over here. And so, basically, what that shows is that school siting can be location dependent, can depend on the context of the neighborhood. The school district appears to have influences many different factors. And so in this particular one, I wanted to try to show something a little bit about transportation, since I haven't found too many surveys that have. I found some just basic surveys that have asked about what some of the barriers are and concerns to walking to school.
So Tom, on your last slide, transportation clearly wasn't an important factor to the superintendents in their decisions.
Yeah, thanks for pointing that out. And so, and that actually comes up later on in some of my conclusions, actually. So this is, again, trying to make these connections is very important. And so in this particular one, they just basically said, well, now, as Jennifer pointed out, even though transportation wasn't a factor, they said it's a major barrier, dangerous traffic conditions, a lack of complete sidewalks around the schools, too dangerous to walk or bike around those schools. It makes you wonder what types of surveys have been done. If the school, this is where I started asking planners at the school level, have there been any real studies done around these schools to measure traffic safety impacts? Has the planning departments actually done this? and why not. And so I haven't interviewed any transportation planners, but it'd be a good question I'd like to ask them down the road. And so the conclusion they kind of draw from that, so travel safety environment's pretty significant concern. And so in Beaverton, so this is just basically, I want to just kind of conclude by talking about some of the similarities and differences. And I would prefer to set this up more on a school-by-school basis, but instead I just kind of integrated some of the similarities and differences throughout these last few slides. And so feel free to ask me questions at the end again. And so basically there's there's differences in the purpose of the plan. Only Beaverton, when they wrote this plan in 2002, was required to comply with the state statute. And then Westland Wilsonville wasn't required, but like I said earlier, they did it in 1996, and this is their third plan update. And it hasn't, and so in this particular update, they used 3 different type of growth scenarios. And that's if the UGB, urban growth boundary, doesn't expand compared to if it totally expands around the whole area and what they'd have to look at. And then Tiger Tualatin, even though it's the thickest plan, it's more of a land inventory study, so it's not as comprehensive as the other plans. It kind of answers it doesn't answer all the questions involved with, especially with that state statute, but it does do school enrollment projection needs and land needs, and pretty much suggests about 5 different schools that should be built in that district over the next 20 years. And then Portland Public Schools was more of an operational facilities-oriented approach. And so when I looked at that one and I interviewed a person for that, they kind of just start out by saying, planning's being brought into the education process now with Portland, because of a lot of the significant decline in student enrollments, age of the buildings. But that process was a 3-year process when they wrote that plan, which is quite different than how many of these other plans are written. When you hire consultants, are done within 90 days to 120 days. Doesn't necessarily address any transportation issues in that plan, because it perhaps probably had a different purpose of what they were trying to achieve with that plan. And I just learned that it has such a different set of siting challenges in terms of reducing. It actually uses these 3 R's approach and explicitly says that they want to reduce the inventory of property. And it gives the actual properties of school sites of where they plan to reduce that inventory and sell that off. And reuse other schools as multiple uses, doing some renovation with those properties. Was a real important, was mainly the big discussion in that plan. And then they want to retain some of that currently leased property or non-traditional school use for building for school sites. So because of some of these challenges, and since this isn't a thesis type paper, I've decided to not necessarily compare this with the other facility plans. So I mainly looked at the suburban school districts. And the reason I did that is because they're all located to the western part of Portland, some in the southern parts as well, like Westland and Wilsonville. They all go right up to the urban growth boundary. So they need to identify the different types of growth trends in those plans. And then Beaver, Tiger, Tualatin, large swaths of land are very scarce. And they've showed me in some of their, in these plans about where some are over capacity. Not necessarily every school is over capacity. And what's interesting is in Beaverton, when they subtract the amount of portable schools, they found that 26 of the 46 schools are over capacity. And I learned at one time that this one particular high school had 19 portable classrooms to deal with the demand of students that were going to that high school, which is quite an amazing number. But and then I didn't realize the land value was so high, over $400,000 in many cases per acre to just buy land. And that land is, again, purchased with capital bonds, which is public funds, which in some cases it can make a school over $5 million just to buy the land to even just start building the school. And so the transportation active living issues that kind of arose through some of my interviews and not necessarily in the plans. I looked at school attendance area, size of the sites, and joint uses. The school bus issue came up quite a bit. Kids that only have to walk a half mile to school or bus to school. And if I was focusing more on transportation, I probably just these 3 transportation issues I could look at in a lot more depth than what I am now. The auto congestion around school zones and how some of these plans will state that how you design the drop-off site with the school as separate from buses and cars to talk about that safety. And then in terms of size, that's actually was the first thing that everyone always talked about in my interviews, and they said that could be my whole field area paper, in the sense that there's no requirements in Oregon. There's good and bad trade-offs to having no size requirements, and only about half the states have school size requirements for when they build schools. But the rule of thumb is 10 acres for elementary because it's generally single story. A lot less parking, smaller school. Middle schools get into quite a larger amount of kids, probably in most cases over 450 to 700 kids going to those schools. Required 20 acres in high schools. The 40 acres mainly comes in not necessarily with the size of schools, which I was quite surprised to learn about some of the 2,000 people that go to some of these high schools, which is quite a bit dramatically different than when I used to go to high school. But just for the parking that's needed at those schools, and then for all the different types of fields, baseball fields, softball fields, football fields that they usually build when they build those schools. And so in this, and then the joint uses part was interesting to learn about in the sense that these schools, if I did more of analysis, they are being built next to adjacent parks. They are forming partnerships and talking about that with Parks and Recs Department and using those schools, the school recreational fields as well with other members of the community. And then some of just my other findings before I get to my conclusions is that so these plans, as everyone said, would be prepared for future capital bond measures. What was the most interesting finding, though, was that these school districts are all in multiple jurisdictions. So when they're writing this plan, for example, in Beaverton, these are all the school districts they have to deal with. They have to deal with the city of Beaverton, the Hillsborough, and Tigard City. And they also have to deal with unincorporated Washington County and Multnomah County. It's all part of their district when they're coordination that has to go into writing that plan. And then the school facility planning committee structures in Beaverton and West Lynn, they did have a little bit more of an extensive outreach in Beaverton and West Lynn, unlike the one in Tualatin, because that was just more of a land inventory. And if you have any questions about that, I'll try to answer some of those later. But what I found was interesting is that West Lynn actually has a surplus of land. The only one that announced that. And they have quite a bit, actually. They have, I think, something like over 50 acres because they were trying to be proactive with how these plans were developed and trying to prepare for themselves for the future need of schools, into 2020, 2030, when they bought some of these land back in the 70s. And so just some more findings is that these school officials, they acknowledged there was good cooperation with the citizens, planning officials, but they kind of had these questions they always threw out to me. The state statute says that these plans are supposed to be implemented as part of the city-county comprehensive plan, but they kind of wondered how that's going to be implemented and how that's when they adopt it, what they're actually going to do for building those future school facilities. And I guess it really depends on the relationship that's set up with the city or the county. And so they would always ask how would the transportation infrastructure be planned around that area and what types of pedestrian bicycle friendly environments. And then I might ask them back why they didn't, in that interview, why they didn't necessarily address that in the plan. So usually I had to step back from that question during my interviews because some of them, that wasn't the focus of the plan. So, but that was something I kept finding coming up over and over again. And then this is a very reactive type environment for building schools for building schools that the school districts work in. And so, even though Beaverton said that they were being more proactive in buying land outside the UGB, they bought one school back in 2000. Metro, when they were coming up to do the expansion, started talking about how much land, certain areas they would expand around the school, and then they ended up expanding 1,600 acres around Beaverton. And this is kind of the map right here of where they own some of the land. This is a newer map with the UGB brought into it. And so what's interesting is that this is the only land they own, but around these school sites with the amount of density that could go in there, you can see that. That they might need 2 to 3 more schools as well. And so there was some friction, some difficulty, I guess, that they had when they went and testified in front of Metro and explained to them about what the need would be for school and their projection in dwelling units. And they bought this land with capital bond money before 2002, and they're not up for new capital bond money until most recently. So that was just another major issue that came up. And so, and then Westland had a long-range planning committee, which they've always had an active committee in the last 10 years as they plan. It's a citizen-driven committee, and so that was good. That was interesting to hear. And so, with Beaverton and Westland, then there's a site selection process, and these are just basically some of the comparisons they have with that. And this is the size and location that they look at with sufficient land, utilities. With road classification, I found studies that middle schools and high schools are supposed to be built next to arterial streets, which was an interesting finding, not necessarily elementary schools. And then the timing issue of when they should buy the schools, the cost. And the cost was, in Beaverton, was the most interesting because these developers are trying to compete with schools of how much they're going to pay for land. And that's not necessarily always in their best interest to get in a competing war. And they started bringing up condemnation powers, which is something, as some school official says, the big C that no one likes to talk about with school facility planning, to the condemning land and taking that away from the property owner. And then Tualatin, from what I understand, they didn't have any adopted guidelines, so there was some suggestions for what their type of school selection for the size that they should look at. And then the zoning issues, the connection between transportation and land use. State laws prohibit developments being denied based solely on the lack of school capacity. And so in Washington County, with the West Side Max going out to it, schools aren't allowed in those transit-oriented developments, residential, commercial, of 12 or more units per acre. And only elementary schools are allowed on sites less than 7 acres with 9 to 12 units per acre. And so, but there's basically not much land available because there's lots of environmental constraints, as I showed in the last slide, and definitely many other factors that go into that. And so, in terms of the overcapacity, this is the last little one I wanted to show in terms of on this. And so this was done by the Portland State University Population Research Center to show actual enrollment and then the projected enrollment for elementary schools in Beaverton, to show that there's a clear need in the long term, that there's going to be going from 16,000. That's what if they kept the schools at not building any more schools, that would be the capacity right now, and with an additional, 6 more thousand students coming into that district, especially with the expansion of the urban growth boundary. And so my conclusions are, I have quite a few of them, and I just wanted to show that when Mary Vera Katz received her Pioneer Award back in April 2005, there was an announcement made that the most important infrastructure in our community is our schools. And when Mike Tannenbaum, who I interviewed, and Deputy Superintendent Wes Lynn said that the quality of schools and the kind of education has a lot to do with the value of the city for the people moving here. And so some of my conclusions, if some of you were wondering about how many schools are they going to build, just for example, in 2020, to address those school capacity issues, Beaverton needs to build 11 more elementary schools. It states it right in the plan. According to their officials, they probably have about 4 elementary schools. They might, right as it is right now, that are planned and have land available to build to deal with that school capacity. They're all looking at smaller school sites, but people are also looking at different 2-story schools, but that doesn't necessarily save in the amount of land. I think they said it might, in one school in Tualatin, they said it saved 1/3 of an acre if they went with 2 stories instead of 1. The expansion of current campuses, because some of these schools are older, they do have a little bit more land around them. Building K through 8 schools, just switching it all together and getting rid of some middle schools, which they've suggested doing in Beaverton, and conversion of existing schools from middle schools to elementary schools to kind of project where that growth is. So as the kids move out, grow up, then they can just convert. They have these plans in place to convert the different schools. And some of the land that would be set aside that Beaverton owns, they could build another new elementary or middle school. And then this was the most contentious part, which was buying the contiguous parcels to assemble the school site. And so in Beaverton, they had to buy 12 parcels of land to assemble one 10-acre school site. And so that's 12 different property owners they had to deal with in buying these properties of land, which they said was like a 2-year process just to buy those parcels of land. And then everyone acknowledged there's security issues and access. When I talked about transportation, walking, biking to school after the Columbine incidents, limiting access to schools, having fences built around schools, only having one entry point into schools, not necessarily having schools and roads go right up to the school. There's different types of variances people can apply for, which I thought with the big health issues and big craze now getting kids more active, it'd be important to look at that. But not a lot of school officials necessarily would state that it's in the best interest of the school district to build more pedestrian, bicycle-friendly environments. And then one suggestion came up about developers holding the land in trust to build infrastructure around the neighborhood schools, which I thought was a brilliant idea. If they could put some money down on it and then get a capital bond to pass, they could buy that school later from the developer, and they could start planning and building the infrastructure around that school and start getting that in place, because you don't necessarily build schools before you build the cities or build up the community. That's not necessarily how it works nowadays. And so I've been talking about this term for the last year, and I really want to try to define this term as I go forward with this paper about school-oriented development. I feel like it's not something that's really been discussed much in terms of the planning, school facility planning and planning fields in general. Kind of plays off the term transit-oriented developments. And I just want to, I'm going to have to define it in terms of, should it mean smaller school sites, compact neighborhoods, more accessible multimodal communities? I'm still trying to draw those conclusions when I put together my final report. Creating school facility plans it's important in general just to do it for all schools. It's not, you don't have to be required by the state to do it. And I didn't get into system development charges, and schools don't receive those types of fees. Though what was interesting is that when they're partners with parks, and when they go to construct their school, they have to pay their project partner, the parks. They have to pay system development charges that goes to the parks. And so they're wondering how those fees could get waived, if anything. So that was quite an interesting finding that I had. So North Clackamas School District is currently writing a school facility plan, and there's other UGB expansion areas that are planning for schools in the Pleasant Valley, Damascus, Boring area. And so these plans, I think they should explore more land use, transportation linkages, set up different purposes of the plans, and then to create more of a transparent process to pass these voter-approved bonds, which is what some of these communities are doing, but you might always read about them in the newspaper and how schools are just more reactive to growth, and it's not the responsibility, as a North Clackamas Plan Commissioner said, for them to build schools. It's the school's responsibility. So that's right on their district website, actually, when I was reading about that. And so as I was showing you earlier about the survey with the superintendents, you get to get them become more of the champions of building these neighborhood schools. And so you just have to look at building schools on the neighborhood level, look at different funding sources for capital improvements. If there's funding available, to have dedicated for school facility planners in terms of building more partnerships with schools. And then finally, just looking at more studies that should be conducted around these schools, different types of subdivision, zoning, regulation improvements that come with comprehensive plan updates, and just in general looking at how these land use review applications are approved or not approved based on school capacity. So I thanks for all your time and coming here today. These people are real important to help me write this paper. Countless emails through some of the professors, Jennifer Dill, Cy Adler, Irina Shirkova, and Ethan Seltzer, discussing this idea. I took classes in transportation land use with Bruce Appleyard, Bethany Johnson for giving me some of this data, and then the people that I interviewed, and then all my family that's watching from all over the country today. I make sure I want to thank them for listening to me talk about this idea hours upon hours, and talking about with all their kids, trying to get them active and walking and biking more to school. And so if you have any questions, I know it's almost time to go, and you might have quite a few questions, but I hope it was quite informative of what I was talking about today. And if you have any suggestions for me, not necessarily on the presentation, but on the issues of school siting that I should look into, or how to make some more connections to transportation, since that's all you're taking this class for, with land use, feel free to ask. So. Jennifer?
In your interviews with the district people, did they seem, did you bring up the idea of sort of health and physical activity, and what was their response? Did they seem open to it, or did they just sort of bring up barriers and problems? Or
they actually all, I would say that they all said that in theory, perhaps because I was a planning student, that it sounded like a great idea. And I think one person said that, oh, it'd be great to have kids walk and bike to school and sing Kumbaya, but that's just not the reality of how we can go plan and build for schools. And she's actually turned out to be a close friend of mine now in terms of helping with my data, and she was probably the most helpful in terms of saying that it's they don't point fingers at whose problem the barriers to schools are. They don't try to say it's and I don't think they were trying to protect their image or anything of saying that it's the school, it's the planning officials, it's all them, it's their responsibility. And they don't say that it's the parents' fault either. They say that because of so many constraints, they just can't find sites that with large amounts of land that are suitable for building an environment that's safe to walk and bike to school. And they all wanted to talk about, as I said, about the joint uses of those schools, but we didn't get into, well, are all those kids driven to school or driven to go to those areas? What does the city do in terms of, what does a school do in terms of having programs that encourage kids to walk and bike to school? We didn't get into any of that type of discussion. I don't know if that necessarily answered your question, but there's 4 different ways to answer that question of how they would look at it. Yes?
Could you use the microphone so people can just touch the touch. keep it.
Oh, I see. In interviews, did anybody mention the CEFB standards that have recently been relaxed for a minimum acreage for schools?
In terms of, was that a federal standard?
Yeah, CEFB has always had this, I don't know how long, they've had minimum acreage standards that they recommend, and the federal government sort of propagated that throughout the United States, and recently they've relaxed that. And I'm wondering what kind of difference that's making, if any, or whether people are locked into the 10, 20, and 40 acre thing here in Oregon, whether the CEFB standards being relaxed is making a difference in school siting.
Well, I noticed in some areas that they had standards as low as 5 acres for building some of those schools. I think what some of the issues are mainly, as I was trying to talk about earlier, is really, it's not that they don't want to build on a bigger site. It's just finding that available land and paying, and who's going to pay for it. It's not, and if they could buy the land on 10 acres, they would prefer to do that. I mean, I don't go into all the design and construction of the schools. I think what's interesting is that the schools I'm trying to think of how it is that if they could the land is that everyone's building on is so much farther outside of the inner neighborhood, and they don't want to go through the process of trying to buy like contiguous plots of land and trying to go through that competition and that bidding war. And if they don't have like a dedicated funding source of like system development charges or a general fund that doesn't go towards the operational, then they can't do that. But I think to answer the question in general is it's these plans like this. It's doing these types of studies, these types of projections that actually will plan ahead to buy those school sites and to look down the road of where that land is going to be. Because what happened is in some of these plans they said that they bought land in the southern part of their district and no one moved there. And so they have all this surplus land that they have no use for it. And they don't know what they're going to do. And I think I showed earlier that West Linn is going to, at the end, going to be doing a community summit in June to ask the community what they should do with this land and what should they do with the money after they sell this land, and where they can buy those areas. But you're asking a really important question in terms of how they should coordinate and work with developers, and how developers could necessarily work with school districts to set some of this land aside or sell it to them. But I didn't get into all that. I'm not getting into a large, deep discussion on that issue. So,
okay.
All right, thanks.
We're at 1:30. Before
Thanks.
we thank Tom, I'm going to announce next week we have 2 more of our MURP students talking about the research that they've been working on. Matt Lasky is going to talk about understanding the link between bicycles and light rail. And Jay Renkins is going to talk about the effect of grocery store size on shoppers' travel behavior. So thank you very much, Tom, and again, Steve.
Thanks.